Okay, this is Miss Hobbs with the Minds on Physics, and I'm going to be walking you through the mechanics unit, specifically work and energy, and we're going to be on Mops 5, which is the difference between internal and external forces. And the difference between internal and external forces isn't actually that important. It's more important to understand how they change the amount of energy in the system. Internal forces are what we would be considered conservative forces. And I would write this down as you guys listen and take notes so that you have this as a reference. And what conservative forces mean that the net energy is the same throughout the system. Okay? So for the force of gravity, when the force of gravity is working on a system, say it's making a rock to fall on an unsuspecting passerby, that falling rock is losing potential energy. But as it's losing potential energy, it is gaining kinetic energy. So the total amount of energy in the system remains the same. The same with a spring. As you compress the spring, you are doing work. And as that work is being released, when the spring is released, that work and that potential energy is transferred into kinetic energy. So in internal forces, the energy stays the same. And external forces, like the force applied, so a general push or pull, the force of friction, the force of air resistance, and the force of tension and normal force are all what are considered non-conservative forces. My R's look like my V. That's okay. And what non-conservative forces mean is that you can gain or lose energy. Okay? The way that we gain or lose energy is by work. And what work is, I have no idea what happened there. There we go, we're zooming back to the normal. One moment, guys, this is like the 5th time I've had to take this, so I'm not giving up. No, there we are. Non-conservative, you can gain or lose energy, and what happens is that is the work, work equals force times distance. And when you apply a force, you can actually change the amount of force in the system. So work can be positive, which is going to add to the system, or work can be negative, which is going to take away from the system. So you can do negative work when it is the opposite of what the system is going through. So the example that we could have for that is the force of friction opposes the force applied, and so the amount of work would be done would be less if the force of friction, or excuse me, more if the force of friction wasn't there. Okay? So what happens is the amount of force or the amount of total energy in the system for an external force the amount of total energy in the system for forces that are external can change, where the total amount of energy in the system for forces that are internal stay the same. Okay? So force of gravity and force of spring, if that happens, you know that the net energy in that system is the same, and you can do the potential and kinetic energy transfer stuff. The external forces, you need to be able to figure out what work is being done. If that work is positive, you need to add that work to the system. If the work is negative, you need to take away that work to the system. Thanks for your patience on the technical difficulties, and this will get better and better as we go on. Again, this is for Mops 5 on the work and energy unit in the mechanics unit for the physics classroom. Thank you.